The European Space Agency, ESA, gained international recognition for sending a probe into the direct vicinity of a comet for the first time with the Rosetta-Philae probe. This is significant for two reasons. Intensive comet exploration is vital to humankind here on Earth. We need to learn more about comets if we want to better understand our origins and protect our existence before we share with you the unsettling results of the Rosetta-Philae mission. Comets are thought to be the possible origin of life in space, but some of them can also kill life when these chunks of ice and organic materials, sometimes a few miles in size, collide with planets. Catastrophes of apocalyptic proportions occur. We encourage you to subscribe to our channel in this video so that we may continue to provide you with videos about the most recent NASA missions and space discoveries. We would appreciate a thumbs up if you enjoyed the video. Now let's give you a brief overview of the Rosetta mission's target. The 67P Churyumov comet Gary-Semenko. At one time, Comet 67P Churyumov-Garrison, also known as Chury, was one of the numerous objects that orbited in the Kuiper belt at the very edge of the solar system. Later, Chury moved to an inner orbit and is now one of the comets that are bound to Jupiter, meaning that its overall very elliptical and irregular orbit rarely extends beyond that of Jupiter. Chury is a 2.8 by 2.2 mile chunk of dirt, ice, and organic material. Churyumov is compared to asteroids. A comet that most likely formed in the early solar system might have even come from the same dust cloud that gave birth to our sun more than 5 billion years ago. Asteroids are made of enormous rock and typically include a very high proportion of metals, whereas comets are less massive but not necessarily smaller and typically exceedingly deformed lumps. Because comets are the only known source for the propagation of life in space, researchers believe that comets like Chury may serve as cosmic messengers. This is because comets are mostly composed of ice and organic materials. Comets are one of the most widely accepted theories for how vast volumes of water and perhaps the earliest elements of life could have arrived on a once hot, hostile, and dead planet. Even before the double probe could finally land on the comet's surface, Rosetta detected significant amounts of oxygen. The Rosetta Skin probe measured the comet's environment during this process, and the Flying Investigation Laboratory made its first discovery that shocked scientists by revealing that Chury has an extremely unusual atmosphere after water vapor. The fourth most prevalent gas is carbon dioxide and carbon monoxide. Since oxygen is typically a highly reactive gas that dissipates quickly, no researcher has yet to consider the possibility that a relatively small object like a comet could trap large amounts of oxygen in its thin atmosphere. At this point, researchers can only speculate as to where the oxygen originates. One possibility is that the oxygen was trapped in the ice when the comet formed, but this would imply that the comet was born in an area where oxygen was present. To date, no planet in the solar system has been found that even remotely has an atmosphere that is suitable for human habitation, such as Mars, which is currently scheduled for human habitation. Colonists on Mars would need to wear helmets. The fact that the air is constant and contains enough oxygen for us to breathe makes us realize once more how precious and special our wonderful planet is. Numerous fortunate events have made organic life possible on Earth, including you and me. The reasons why there is water, a pleasant climate, air to breathe, and living things here are among the greatest mysteries of science. When the Earth was first formed, it was a hostile place that was hot, rugged, and toxic. Then, billions of years ago, water appeared, and the first single-celled organisms and bacteria appeared. To this day, the big question is whether the first single-celled organisms and bacteria came from nowhere or from somewhere else in space. Even though the European Space Agency frequently collaborates with NASA and is heavily involved in the International Space Station, ISS, Rosetta-Philae is regarded as the agency's most ambitious and successful project to yet. Additionally, Europeans desire their own space initiatives. Missions and probes, the exploration of comets and asteroids, could become the flagship of European space travel. It is imperative for us on Earth to learn more about celestial bodies. In the asteroid belt between Mars and Jupiter alone, there are 650,000 objects made of rock ice and metals thanks to the gravitational pull of the gas giant Jupiter. Most of these chunks are kept in their orbits and thus at a safe distance from Earth. Nevertheless, there are about a dozen comets or asteroids that could sooner or later find themselves on a collision course. With Earth, currently all of these celestial bodies are being intensively observed, If one were to come too close, we would have to use probes such as Rosetta-Philae to find out if the threats are composed of rock and ice so that we can destroy them or deflect their orbits if necessary. Consequently, ESA's work and exploration of Comet Churyumov-Gerasimenko is a true pioneering achievement in this important respect. As well, the Rosetta-Philae probe was built at the Friedrichshafen facilities of the German aerospace company EADS Astrium. A total of 17 nations participated in the construction of the probe, which cost around €1 billion, and Rosetta-Philae will certainly not remain the only project of this type, following its enormous success. The probe was named after the Egyptian port city of Rosette, and the lander after Philae Island in the Nile. In both locations, stone monuments were discovered that allowed humans to decipher the writing of the ancient Egyptians' hieroglyphs for the first time, just as the discovery of a mysterious script thousands of years ago illuminated the Egyptian culture. The Rosetta found a double probe should help us understand the origin of life and water in space, as well as the structure and nature of comets. Before we move on to the question of whether the water on the comet is the same as the water on Earth, let's examine the drama surrounding the near-death failure of the Philae probe to land and its most important discoveries. The Philae mission on November 12, 2014, those in charge of ESA's control center held their breath. That was the day Rosetta set down the Philae lander on the comet, or rather simply dropped it. Never before in the history of spaceflight have humans set a lander down on a comet. The maneuver to place Philae, which measures only 1 by 1 meter on the comet, which is about 2.8 miles long and 2.2 miles wide, was considered a technical challenge that was very difficult to calculate. Just calculating the orbits in which Rosetta could approach the celestial body, which was traveling at an incredible speed compared to its size, was a technical challenge that ESA mastered superbly. However, things became problematic during Philae's landing attempts when Rosetta launched its little brother. Hundreds of technicians, engineers, physicists, and mission managers knew that a decade of preparation and €200 million would be at stake. Philae missed its target on the first landing attempt and departed after 2 or 3 bounces on the comet's surface, but finally had of course been pre-programmed for such mishaps. The lander made its second try at landing after 2 more hours of orbiting safely away from the comet, but this time it failed at ESA due to the tension. Rose's third attempt was a nail-biter, but after another maneuver, the landing position did not match the intended location and ultimately lay in a horrible inclined position. Nevertheless, the small probe was able to complete its measurements and photo work as planned. Following this nail-biter, ESA's first action was to pop the champagne corks. Despite the probe's unsatisfactory positioning while they were still celebrating in Paris, Philae had long since started working on the comet's surface. Even during the landing tests, Philae's infrared cameras were operating at full speed, and the lander took its first close-up images of the comet. This gave Earthlings their first chance to see the comet's heavily rugged surface up close for the first time. Around the landing site, Philae discovered a layer up to 6 feet thick of rock regolith, which is very common in the solar system. In addition to gravels, Philae was able to take close-up photos of blocks of rock up to 16 feet in size. Close-up images also reveal a deposited layer of sand or dust, likely formed by movement and erosion of the coarser rock layers. Along with the existence of water and oxygen, the mission also provided scientists with the rare chance to measure the composition of comet dust, which revealed a complex mixture of intriguing organic compounds like carbon, sodium, magnesium, aluminum, silicon, calcium, and iron. In addition to providing clues about the comet's organic and living nature, the dust from comets is also the cause of a phenomenon that we humans are all too familiar with. When comets approach Earth, as the comet Hale-Bopp did in March 1997, these stunning celestial bodies are distinguished by their peculiar gleaming and, strictly speaking, their 2 tails, one made of dust and the other of gas. While the gas tail, which is composed of carbon, dioxide, and water, reacts with the solar winds, the dust tail follows the comet's orbit and glows from sunlight reflection. To end the video, we now resolve the intriguing question of where the water on Earth came from and whether comets like Churyumov-Gerasimenko actually brought it to our world. Another Rosetta-Philae foot was filming and measuring directly from the comet's dust and particle cloud. Our water does not come from the comet. Despite the remarkable success of the Rosetta-Philae mission, the question of how water came to our Earth or how it formed here must remain unanswered. Of course, we would like to know what you think about these exciting and so far unique findings on the comet. Do you also think that the exploration of these impressive but also threatening celestial bodies is of great importance for us on Earth? Please share your thoughts and ideas on the subject in the comments section. The measurements of Shuri's ice structure clearly showed that the structure of the water from which this ice was formed billions of years ago does not match the structure of the water on Earth.